As I already said, the fabric interconnect is where the rubber hits the road when it comes to deploying the UCS B-series server. And that's where we're going to spend the lion's share of our conversation, because it's where we have the most complex deployment environment. Once you learn the UCS B-series methods and operational modes, C is pretty much a cakewalk. So from the perspective of implementation, what I want to do is I want to go to a whiteboard. Now on the whiteboard, what I want to do is I want to talk about functionality. And one of the most basic types of functionality that we have to concern ourselves with is going to be how I am going to take my server. So let's pretend that I have a chassis here, and I'll draw one IOM on the left side and one IOM on the right side, and we'll represent those 8 slots like so, whereby this is going to be blade 1, blade 2, blade 3, 4, 5, 6, and 7, and 8. Now, the significance of this is that these numbering values do have meaning. So again, what I'm making reference to, and I wanted to bring us back to the 3D here, I'm talking about the B-series, and just for clarity, I'll again pick on the mini. What I'm doing is I'm making direct reference to the fact that I have 1, 2, 3, 4, 5, 6, 7, 8 slots. Now, the slot that the server takes is going to be its identity. So the blade in slot 1 is called blade 1. The blade in slot 8 is called blade 8 if they're all half-width blades. However, in the instance where these 2 blades are full width, they take the number of the leftmost slot. So in this scenario, blade 5 would actually be the blade that resides in both 5 and 6. But what I do is I'm going to make reference to it based on that slot designation. So in this instance, what we're going to do is we're going to pretend that we have 8 servers inside of, remember I said that this was referred to as a 5108 chassis. Now that means that these devices need to connect to the outside world. So as an example, let's pretend that we have a layer 2, layer 3 network, and I have servers running on these blades, but I also have users in the network that need to access these servers. So we mentioned the way that we would provide this connectivity would be through the deployment of a fabric interconnect, or an FI. In fact, I usually call these FIA and FIB. Now, from the perspective of this, with regard to implementation, there are a few important things that we need to keep in mind. First of all, these 2 devices, for the purposes of control, are going to act as one unit. And they're going to do that through the formation of what we refer to as a highly available cluster. Now, in order to be able to do that, and to do that efficiently, we want to make certain that we dedicate connectivity resources to give me the capacity of being able to exchange information out of band. Now, what that means is I do not want the communication between FIA and FIB to eat into the available bandwidth that I'm going to be extending to my users through the deployment of this solution. So what we do is we are actually going to connect the 2 devices together using just a regular old-fashioned set of Ethernet cables. These are going to be 1 gigabit Ethernet cables. And we call this the L1 connection, and we call this one the L2 connection. The importance of these is that the L1 must connect to the other L1. The L2 must connect to the other L2. They cannot be cross-connected, nor can I have any type of switching device in the middle. They are supposed to be directly connected to one another. And it's through this connection that I'm going to get the capability of being able to create a highly available cluster by dedicating resources to the FIs that will not need to be taken from users. So again, as we start looking at the implementation here, keep in mind it's going to be the fabric interconnect that is going to afford me connectivity to the outside world. I will have connectivity from my fabric interconnects to my layer 2, my layer 3 infrastructure. I also have the capability of supporting things like port channels. I could be running a virtual port channel. Remember that from the DCUCI exam studies? I could be running a virtual port channel, and the fabric interconnects can actually connect to both of those switches in that VPC pair. It's also going to be important that I may have storage resources. So let's say I have a SAN array sitting out here. So this is going to be where I can store boot information. Well, I could actually have a number of switches. These switches could be connected to the SAN like so. So this would be, say, for instance, MDS1, and we'll call this one MDS2. And my devices could be connected like so, such that I maintain that idea of islands of SAN where I actually have fabric A and fabric B. And if I had so chosen, I have the capability inside of my device, I could engage something like multipath I/O, where I could do something similar to link teaming across those connections for simultaneous forwarding of storage information through fabric A and fabric B. For the most part, they would operate in failover and standby, or primary and standby. So when we start looking at the implementation here, keep in mind, like I said, we have the fabric interconnects that are going to allow us to be able to connect to the outside world. But we also have to take into account that we need those IOMs, those input-output modules, which what we will ultimately end up doing is connecting to each of their own fabric interconnect. Remember, at no time do I ever want to support a configuration where both IOMs inside of the same chassis is going to be connected to the same fabric interconnect. For the most part, I try to go left to left, right to right, or left to top, right to bottom, depending on how my fabric interconnects are actually deployed inside the cage. This is very, very important. So keep in mind, it does not have to be the same way, but the golden rule is that IOMs must always be connected to separate fabric interconnectors or fabric interconnect switches. Now, the whole idea of being able to do this is to support all the features that we need to work with. We need to be able to support Ethernet. We need to be able to support fiber channel. We may need to be able to support fiber channel over Ethernet, a converged network service. I may have to support iSCSI for remote boot. And it's through this deployment method that Cisco gives us the optimum amount of flexibility when it comes to deploying the fabric interconnect and any number of chassis that are going to also be attached to it. The cool part about this is that ultimately I manage everything from a single IP address. Now when we look at that, that's also very important for us, because when we look at this, keep in mind each one of these devices has its own management zero interface. And you may remember our conversations in DCII where we talked about split brain behavior as it relates to objects like Nexus 5Ks and 7Ks operating in VPC. Well, Cisco made the very, very intelligent decision to mitigate that where and when possible when configuring and installing fabric interconnects. So what ends up happening is that these two fabric interconnects are actually going to operate as part of a cluster. Each one will have its own management IP address. Let's just say it's 10.1.100.x/24, where this fabric interconnect has an address of 101. This one has an address of 102. However, between the two of them, they have a cluster IP address that would be 10.1.100.100. Now, interestingly enough, this IP address is actually going to reside on one of these two fabric interconnects. So the moment I bring my fabric interconnect pair up and make it operational, we're going to have an election, and we're going to pick who's going to be in charge. We call that fabric interconnect the primary. The device that did not win the election is going to be referred to as the subordinate. And what he's going to do is he's going to wait until such time that the primary fails, and then he is going to assume all management roles. Keep in mind, we're talking about a high availability cluster that is going to govern configuration and management, not data forwarding. So I could completely lose the ability to manage the box. However, I could still simultaneously be forwarding data out of both fabric interconnects provided my configuration is operational. This is all very important when it comes to deploying the ACI and figures prominently in everything that is involved in getting the system set up. Now, the other part of this that's also equally interesting is the way we manage it. So as an example, we are used to using SSH or Telnet to be able to connect to a device and manage it individually. You should remember that from DCII. Remember, we would connect to peer or VPC peer A, we'd do configuration, and we would connect to VPC peer B and we'd do configuration there in the hopes of being able to bring up a VPC domain. Well, Cisco in its wisdom opted to minimize the probability of this being happening. So what they did is even though I have an operating system, so I have NXOS running on an FI, in fact it's running on both of them, what Cisco did is they chose to make that operating system read-only. And they slaved control to a specialized piece of hardware called an ASIC. It's called the UCS ASIC, the Unified Computing Systems or Computing Systems Manager Application-Specific Integrated Circuit. And it's going to be the device that is the primary that is going to be hosting the virtual IP. So when I go in and make a configuration, unlike a Nexus OS, where I need to SSH or Telnet, in order to do this inside of the UCS, I'm going to have to browse to the IP address of the virtual IP that's being hosted by the primary. And what will end up happening is I will do the configuration from a graphical perspective. The thought was here that Cisco made the realization that a lot of organizations were not going to want to have to learn how to do NXOS, especially if they were server people. Had they not, or had they been networking people, maybe this would not be the actual case. But as far as this goes, almost all of our configuration that we do on the UCS is going to be via the UCS M client, which is going to connect to the UCS M ASIC, and we are going to have to make our configurations graphically, which means we're going to do things through the deployment, configuration management, and monitoring of objects. Yes, we're talking about an XML API that is going to be part of the Fabric interconnects and served out by the UCS M. So with that being said, what I'd like to do is I would like to go through the appearance, show you what the UCS M looks like, and then what we're going to do is I'm actually going to go through and build a UCS cluster from scratch. Oddly enough, we're going to do that using the command line or the CLI. So I'll see you guys in that walkthrough. I'm Terry Vinson, and I'd like to thank you for learning data center with me.